Hello everyone, my name is Rishabh Pal. Welcome to my YouTube channel. Here in this channel, I am going to cover many important and interesting topics of physics, which helps the student who are preparing for competitive exams for physical sciences like IIT JAM, JEST, TIFR, CSIR-NET, etc. And also for the students who are pursuing their bachelor's and master's in physics. Now, for today, I chose the topic of simple harmonic oscillator from quantum mechanics. Hope you all would like it. Now let us start the video. The problem of simple harmonic oscillator can be approached by two ways. First, by the analytic method, and the second, by operator method. In this video, I am going to explain analytic method. For analytic method, we know that Hamiltonian is nothing but the total energy of the system. H psi equal E psi. Here, H is the Hamiltonian of the system, E is the energy eigenvalue of the system. Now, E psi equal P square upon 2m plus Vx. So, here P is the momentum and V is the potential energy of the system. Now, E psi equal minus IH cross is whole square upon 2m del square psi upon del x square plus P, as we know that in quantum mechanics P stands for momentum and its expression is minus IH cross del by del x. So here P is square, so the square of minus IH cross and the square of del by del x with respect to psi, we got del square psi upon del x square. Now here Vx is the potential energy of the system is here, so in quantum mechanics the potential energy function can be expressed as half m omega square x square psi. Psi is wave function. Now E psi equal minus h cross square minus as we know that the square of negative is positive and the square of I gives us minus 1. So here minus h cross square upon 2m del square psi upon del x square plus half m omega square x square psi. So this is the time independent Schrodinger equation. As in this equation there is no time term exists. To solve this equation in quantum mechanics, we are going to transform this equation in some other variables. Now suppose m omega upon h cross under root dot x equal xi. This is a Greek symbol called xi. Now we have to find the value of del square psi upon del x square. So del psi by del x, we can write it as del psi by del xi and del xi by del x. Here when we find del xi by del x, so this x is vanishes, so like del xi by del x equal m omega upon h cross. So this del xi by del x we can replace it by m omega upon h cross under root. So this del xi by del x value is here and del psi by del xi I can write here, and del psi by del x is as it is. Now for the term second derivative of wave function del 2 psi upon del x square, I can write that del by del x dot del psi by del x. Now the value of del psi by del x is this m omega h cross under root del psi by del xi, m omega h cross under root del psi by del xi, and this del by del x. Here I can multiply del xi and del xi here, so it can be expressed del upon del xi and del xi upon del x. So del upon del xi and del xi upon del x, and this del xi upon del x is as it is. So del by del xi is as it is, del xi by del x is m omega upon h cross under root, so I can write it here. The value of del psi by del x is as it is from here. Now under root into under root, that under root cancel out, we only got the m omega upon h cross here and del xi term. As under root cancel out here, m omega upon h cross is there, del 2 psi upon del xi 2 and del 2 psi upon del x square is here. Okay, if you have a question that how del 2 psi upon del xi square could come, so d and d, this is del square psi and del xi, this is del xi whole square, so del square psi del xi square, here it comes. Now on putting the value of del 2 psi upon del x square in the time independent Schrodinger equation, is just like this is the time independent Schrodinger equation, and now when we put the value of del 2 psi upon del x square, this term, so the value is that minus h cross square over 2m, del 2 psi upon del x square is del 2 psi upon del y square dot m omega upon h cross plus half m omega square x square. How can we find x? So as we know that previously we assume that m omega h cross under root dot x equal j. So to find out the value of x, simply we get x equal h cross over m omega under root dot j. Okay, now for x square, j square. Now when we put this term x square in the time independent Schrodinger equation, we get minus h cross over 2m del 2 psi upon del j square dot m omega upon h cross plus half m omega square x square. So under root and square will cancel out. There is omega h cross upon m omega j square, and that psi equal e psi. Now we have to multiply both the term, divide the term by minus 2 upon h cross omega on the both sides, like minus 2 upon h cross omega, and here minus 2 upon h cross omega. And like this is h square, this h cross can cancel this h cross, m to m, omega to omega, m to m. Now we have left that h cross over 2 minus del 2 psi upon del j 2 omega, and this omega I can take whole minus h omega upon 2 as a common. Okay, that 1h and omega upon 2 minus sign is here in this term, and from this term the minus sign is here. 1 omega which comes out, h comes out, and only j square psi left. Okay, and multiply by minus 2 upon h cross omega, which cancel out. Minus 2 e psi h cross omega. Okay, this and this will cancel out. We only left with minus 2 e psi h cross omega equal del 2 psi upon del j square minus j square psi. Okay, so this equation is come from there by dividing minus 2 by h cross omega in both the sides. We get this. Now we assume that here 2e upon h cross omega equal k, which can be treated as constant. So equation becomes del 2 psi upon del j square minus j square psi equal 2e upon h cross omega k. So we have left with minus k psi, minus k psi. Okay, this equation, this is as it is in this equation, and 2e upon h cross omega is becoming a constant k and psi. Okay, now minus k psi term is here, plus k psi and equal 0. So I can take here psi as a common, which left that positive k is to towards here, and minus J square is there. So this is our equation 2. Here k is neglected due to high values of k. It possesses very high values on solving, so we can neglect it. Now we only left with del 2 psi upon del J square minus J square psi equals 0. So this is the second order differential equation that in psi, and the solution of such equation can be given as psi equal a e to the power positive J square by 2 plus b e to the power negative J square by 2. So here the first part, a e to the power minus J square by 2 is positive, due to which it offers very large value, but psi being an intermediate positive increasing function, so it can be must neglected. So we have to go only with the negative value, and this term been neglected. Now suppose that the solution of equation 2, this equation, its solution be like psi equal h cross is a function of psi e to the power minus J square by 2. Sorry, this is J. Now differentiating this term, we get differentiating it with respect to J. So psi becomes del psi upon del J. H is a function of J, so here product rule is applied. First I would differentiate this term. H is a function of J, so simply it comes as del H cross upon del J. So e to the power minus J square by 2 is as it is, and for differentiating this I have to keep this as constant. So H is as constant. This J cannot write here. So differentiating this function, we get e to the power minus J square by 2 as it is, and on differentiating this term we get 2J minus 2J upon 2. So 2 and 2 cancel, minus 2J upon 2. So only minus J is left, which is kept here. J is here and minus sign is here. Now again differentiating it with respect to J, we get the second differential of this, del 2 psi upon del J square minus. Now on differentiating this, we have that first function, differentiation of second. Differentiation of this be like minus J is on here, and e to the minus J square by 2 is as it is, plus this function as constant and differentiation of this. So differentiation of this gives del 2 H cross upon del J square, and this is as it is. Okay, now minus sign here. Now here three functions we have. Now differentiating first, we got del H cross upon del J, this function and this kept constant, this differentiation. Now this minus sign again. Now this time differentiation of this is possible, so del J over del J is 1, so we simply write it that H cross 1 e to the power minus J square by 2, H cross 1 e to the power minus J square by 2. Now again there has minus sign, but when we have differentiate this function, this minus is come to multiply with the previous minus, so becomes plus. That is why here the sign is positive. Okay, this is important, so please keep in mind. Okay, so H cross J is constant. Now e to the power minus J square by 2, if we differentiate this function, we get as it is. 1 J is taking to all is multiplied by this, gives us J square. So J square here, H cross is constant, and e to the power minus J square by 2 is as it is. Okay, clear? Now del 2 psi upon del J square equal this function and this is same, this minus sign, and here its minus sign is this. So on adding this we get minus 2 del h cross over del j e to the power minus j square by 2 as it is, plus e to the power minus j square by 2 this, and d2 h cross over del j square here, minus this is nothing, minus h e to the power minus j square by 2 plus h cross j square e to the power minus j square by 2. Okay, now put the above equation in our equation 2. Okay, do you remember that what the equation 2? This is equation 2, k minus j square psi. Actually I want to put the value of d2 psi over dj square. Okay, here, so I can make it like del 2 psi upon del j equal, this is negative, so it becomes positive, and this is positive, so become negative psi. Now I have to put the del square psi over del j square value here. The value is this. Take this value is replaced by this. Now equation becomes, after replacing, this whole value is come here equal this whole value equal j square minus k psi. If psi is multiplied, it becomes j square psi and minus k psi. Okay, now because equation 2 isn't written in the form, so equation makes this unsolvable. Okay, actually here I taking common h cross e to the power minus j square by 2 with these two terms. Here j square is left, here 1 is left. Okay, sorry, here minus sign is there. Okay, now e to the power minus 1 and as common h cross e to the power minus j square by 2. So as we know that in first equation we let that psi is equal to h cross e to the power minus in this equation. This is the value. Actually h cross is the function of j, so j is not written there. Okay, this is the function of psi. Here j is not written, okay, because it is the function of. If we take a common of e to the power minus j square by 2 from the entire equation, this j square by 2, this j square by 2, this and this were left, and equation will dj j plus d2 h cross del j square plus j square minus 1 h cross equal j square minus k h cross. Okay, now take this term in front of the equation, that it is a second derivative, so equation becomes del square h cross over del j square minus 2 del h over del j dot j plus h cross j square minus 1 equal j square minus k h cross. Okay, now when we take in it as a common, now h cross is common, so j square, this is here minus j square, so it can cancel out, and this expression is minus k, the value of minus k is at left side here, so here it is minus. Now this makes a positive, so this equation is called the Harmonic equation, and the solution of such equation can only be determined with the help of infinite series solution. Now again we have to assume that h cross is a function of xi. Now if this is true, then the series of h cross can easily given by a0 plus a1 xi plus a2 xi square plus up to sigma j aj xi to the power j. And if we differentiate with respect to xi at once, dh cross upon del xi equal a1, because this term is not in xi, so it vanishes out. We only left that a1 because del h cross over del xi, so xi vanishes also. It power 1 and xi minus 1 here. Xi minus 1 here, so aj. J, this power j is come. So this is the first derivative of h cross. Now for second derivative of h cross, del 2 h cross over del xi square equal a2 here, xi is not here, plus up to sigma j1 j plus 1 j plus 2 a j plus 2 e to the power j. Okay, now put the solution in Harmonic equation. We get sigma s common, sigma j. Here we have d square h over del xi square, so the value d square h over del xi square is sigma j plus 1 j plus 2 a j plus 2 xi j. So as it is, j plus 1 j plus 2 a j plus 2 xi j. Now minus 2 xi dh cross over del xi, dh cross over del xi, so this value j a j xi j minus 1. 2 xi minus 2 xi is as it is, j a j xi j minus 1 plus h cross k minus 1 equals 0 from the above equation. Now we know h cross is equal to sigma j a j xi j. As we previously discussed about it, like if h cross is equals to sigma j a j xi j, so here in place of h cross this value will put. Okay, now h cross a j xi j, j plus 1 j plus 2. Now in this equation all xi to the power j, xi to the power j minus 1, and this is xi to the power j. Okay, so by taking common we only get the equation j plus 1 j plus 2 a j plus 2 xi j is left, minus 2j a j plus a j xi j left, k minus 1. Okay, j plus 1 j plus 2 a j plus 2 equal 2j a j. This is a minus sign, and beyond equal this is 2j a j. This sign is also changed, and this is as it is. Okay, now we have to find the value for aj plus 2. Ultimately we have to find the expression for aj plus 2 is like 2aj minus aj k minus 1, and this whole value is into this. Now aj plus 2 is equals to 2j minus k plus 1. Here aj I take as common, j1 plus j plus 1 j plus 2 is here, and aj is there. Okay, so this is the required equation of simple harmonic oscillator in quantum mechanics. This equation is satisfied for j equal to n. For j equal n, j equal n, an plus 2, an plus 2, j equal n, 2n minus k plus 1, 2n minus k plus 1, j equal n, n plus 1, j equal n, n plus 2, n plus 1, n plus 2, aj, j equal n, an. Now 2n minus k plus 1 equals 0. Here we consider, okay, actually ultimately we have to find the 0 point energy of the oscillator. So if this expression is equal to 0, then we have to find the value for n. Okay, as we know that the previous, that k equal to e over h cross omega. Okay, so now equation becomes k equal to n plus 1. Okay, actually this is a 2n plus 1 minus k equals 0. So k is the value of k is 2a over h cross omega 2n plus 1. Here if I take n as a common, so n and 1 over 2. Okay, actually I take 2 as a common, sorry, 2 n plus half here, and 2 cancel, e over h cross omega is going to be in multiple of n plus half. So this expression E equal n plus half h cross omega. For this expression, it is clear that the minimum energy required for the quantum oscillator is half h cross omega. For n is equals to 0, E equal half h cross omega. So, which is the least energy of the quantum oscillator and is called the 0-point energy. This is the graph that the minimum or the least energy of the quantum oscillator is E naught is equals to half h cross omega. Ultimately, this least energy is in the oscillator, and after that it is the odd multiple of h cross omega. So this is the analytic method for simple harmonic oscillator. In next video I will discuss about operator method for the simple harmonic oscillator in a quantum mechanics. Thank you so much for watching the video.